Hi everyone. Since we don't have class in person today, as you're doing this video lesson, you're going to fill in the notes. We're going to skip ahead a little bit and then go back since I'm only missing half of you today. So you're going to go to page 27 to 28 in your functions packet and follow along with the lesson. So the title of the lesson is Linear versus Nonlinear Functions. We did talk about what linear means because it has the word line in it, but a linear function is a function that will make a straight line when it is graphed. Okay, the second bullet we haven't talked about yet, so even though you don't understand what I'm going to write here, I just want you to fill it in. You'll understand this by the end of the week. An equation is linear if it can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. And then a table is linear if it shows a constant rate of change throughout the entire table. So we're going to look at functions and say, are they linear or nonlinear? Nonlinear just means it does not make a straight line. Okay. So what we're going to do first is we're going to use some tables of values and graphs. If I can graph it, I can see if it's a line or not a line. So if we look at number 1, they gave us an equation, y equals x squared plus 1. So I want to graph that equation. So what I'm going to do is, in the table they gave us all these values, different values for x, and I want to find what the y value is at that number. So for this first one, it says x equals -2. I'm going to take that -2 and substitute it in for the x. Oops, I don't know what that was. So I'm going to take -2 and put it in place of the x. Okay, so I'm going to do -2, it has to be in parentheses, squared plus 1. Okay, -2 squared plus 1 equals 5. Right. For the next one, I'm going to put in -1 for x. Actually, let me go back here so that you can actually see. Okay, that'll be fine. So let's put in the -1. So I'm going to do -1 squared plus 1, -1 squared plus 1. -1 squared is 1, plus 1 is 2, so that equals 2. Okay, now 0, so I'm going to do 0 squared plus 1. So 0 squared plus 1 is 0 plus 1, which equals 1. Now I'm going to do 1 squared plus 1. So 1 squared plus 1. 1 squared is 1, plus 1 is 2. And then 2 squared plus 1. So 2 squared, which is 4, plus 1 is equal to 5. So now that I have this table of values, these are all actually coordinates, okay? So my first coordinate is going to be -2, 5. So I can graph that point on the graph. The next one will be -1, 2. Next one, 0, 1. Next coordinate is 1, 2. And then we've got 2, 5. So I'm going to plot those down here. We have negative 2, 5, negative 1, 2, 0, 1, 1, 2, and 2, 5. And if I connect these, we're actually going to see that it makes a curved graph. Sorry about the squiggly, but it makes a curved graph through the points. So the question is the function linear? Why or why not? And no, it's not linear because it does not make a straight line. So if it makes a straight line, it's linear. If it doesn't make a straight line, it's nonlinear. Okay, so we're going to do the same thing for number 2. Now we have a different equation though. Now our equation is y equals x, or excuse me, y equals half times x. But I'm going to take the x values and substitute them in. My first one is negative 4. So I'm going to put negative 4 in for x. Sorry, I'm using my tablet and sometimes it has a mind of its own. I'm going to put negative 4 in there. So I'm going to do half times negative 4, which equals negative 2. Right? Then I'm going to do half of negative 2, which is negative 1. Half of 0, which is 0. I'm going to do half of 2, which is 1, and half times 4. This is my first time using DocHub to do this, and I actually think I prefer Kami for this. So half of 4, which equals 2. Okay, so now I'm going to plot these points. I have negative 4, negative 2. Negative 2, negative 1. 0, 0. 2, 1. And 4, 2. And now I notice that if I draw this, it's actually going to make a straight line. Okay, so I've got a straight line. I want to put arrows at the end. So the question oh my goodness. Is the function linear? And yes, because it makes a straight line. Okay. Now, what do you notice that is different about the functions in questions 1 and 2? And they're actually talking about the equations here. So if you look at the first equation, y equals x squared plus 1, there's an exponent here of 2, okay? If you look at the second one, though, it's y equals half of x, okay? And you'll notice that it's just a plain x, which is x to the first power. So the big difference between them is that number 1 is raised to a power other than 1, okay? Whereas for number 2, it is not. So what do you notice is different? Is that the equation with the exponent which is y equals x squared plus 1, is nonlinear. Whereas the one without a numbered exponent is linear. And that is y equals half of x. That's really the big difference, and that's actually why both of these, one is nonlinear and one is linear. Okay, so we're going to do the same thing again. We are going to graph these, and I'm going to do these quickly this time and see if they're linear. So I'm going to just substitute in. I'm not going to write it out this time for every one of these. So for this one, I'm going to take the -2 and put it in for x. Okay, so I have -2 to the third power, which is the caret. The way that you type this into your calculator is -2 caret 3. And that means -2 times -2, which is 4, times -2, which is -8. Then I have -1 to the third power, which is -1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. And now we can graph all of these points on the graph. So I have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So this time if I connected these, and I can't see what I'm drawing, they actually make a curve. Now it is a function because there's nowhere along there where it would cross twice, but is the function linear? No. Okay, and reason being that it's not a straight line. So let's try number 4. So same thing, we're going to take -4 and put it in place of the x. Okay, so 1.5 times -4 plus 2. And you can type that directly in your calculator, which gives me -4. 1.5 times -2 plus 2 is -1. 1.5 times 0 plus 2 is 2. 1.5 times 2 plus 2 is 5. 1.5 times 4 plus 2 is 8. Now we're going to graph those on the graph. So I've got -4, -4, -2, -1, 0, 2, 2, 5, 4, 8. And now this time you should notice that it makes a straight line. So I can draw a line through those points, which I'll have to move just slightly. Oh, I actually messed up one of the points now that I'm looking at it. -2, -1 shouldn't be there. It should be up here. I went down one too far. Okay, I'll put my arrows at the end. And is the graph of this function linear? Yes, this one is linear. If we were in class, you would have caught my mistake. Okay, last one. We're going to do the same thing. So this would be 12 divided by 1. 12 divided by 1 is 12. 12 divided by 2, 6. 12 divided by 3, 4. 12 divided by 4, 3. 12 divided by 6, 2. I'm going to graph those points. We've got 1, 12, 2, 6, 3, 4, 4, 3, and 6, 2. So this would actually also make a curved line, which would not look like that. If you use a tablet at all, I recommend Kami instead of DocHub. I like DocHub for remote for typing and lines, but not necessarily for writing with a pen. Is this function linear? The answer to that is no. Okay. Now, what differences did you notice about the equations that were linear functions and those that were not? So if I look at the actual equations, you're going to notice here we have an exponent, and here we're dividing. So x is on the bottom of the division problem, whereas in this case, we just have x, okay? So x to the first power, or just an x without an exponent. So when x was raised to an exponent, or in the denominator, because that's using fraction terms, the equation was nonlinear. Okay, but just like we said before, in the format actually where x doesn't have an exponent or has an exponent of 1 was linear. Okay. 7, what differences did you notice about the tables that were linear functions and those that were not? So now if I actually just focus on the tables here, and I am actually going to look at the slope in this case. So we're going to look at what were the changes here. Okay. If you look here on the top of this table, this was +1, +1, +1, +1. But here from -8 to -1 was -7. Then here we had, +7, +1. And we had +1, +7. You're going to notice that the slope or the rate was different. If we look at number 5, we have the same thing as these went up by +1, +1. Okay. Here we had -6. Here we had -2. So if we compare these rates, our rates are different. However, when we have a linear function, we have a constant slope. So these were +2, +2, +2, +2 on the bottom, right? So -4 to -1 is +3, -1 to 2, +3, +3, +3. And actually in this case, our slope is 3/2, which is 1.5. Notice that's in the equation we're going to talk about. So when we look at the actual tables, what difference did you notice about the tables that were linear and those that were not? Nonlinear did not have a constant rate. Of change. Whereas linear did have a constant rate of change. Okay? So in most of these cases, on your homework, you're going to graph them. So you're going to be looking at them, and after you graph them, deciding if they're linear, straight line, or nonlinear, make a curve. So what you're going to do tonight is page 29 through 30 is your homework. Okay. For tonight. If you do have questions, you can email me and we'll go over it tomorrow in class. Sorry about the writing that went all over the place, but I hope you guys have a great rest of the day and I'll see you tomorrow. Don't forget to turn this in on Classroom. You have to turn the notes and the homework in.